Should we get started? Okay. So everybody, thanks for coming in right after lunch. I know it's a tough time. So they got you the best presenter possible in the house to get you all waking up and tell you some cool things. So my name is Elad Zeklik. I'm the group manager of the Azure Machine Learning Marketplace. If I had submitted this session last week, I would have called it Behind the Scenes of HowOld.net and how you can, of the HowOld robot and how you can break the internet in 24 hours. That was too late for that, so it's still the Azure Machine Learning Marketplace, but now I actually have a lot of cool stories to share with you from the last week. It's supposed to be fun, supposed to be an interactive session, so feel free to stop me for questions, and if that's not that comfortable, we'll just pause at the end. So for a little bit of warm-up, who is this guy? It's an octopus, but it has a name. What's his name? Paul, and this is the octopus that did what? This is the octopus that predicted the 2010 World Cup soccer, actually football in everywhere else on the planet except here, soccer World Cup in 2010. Okay, that octopus was very, very unique. The way that he did that is he got two mini aquariums filled with food, and they glued flags of countries onto those aquariums, and depending on which aquarium he actually went to pick out his food, that was the predicted winner. He actually did pretty well, I think, getting 7 out of 8 scores right, and was the best in the world at the time. Unfortunately, 2 months after the 2010 World Cup, it, or he, whatever you call an octopus that has a first name, died. And when the 2014 Soccer World Cup in Brazil came about, people all over the world were excited about who is going to be Paul II. And they tried an elephant, and they tried a cow, and they tried, I think that's an armadillo, and for the love of God, I have no idea what this whitish thing is. Somebody actually said that it's an albino porcupine, but I'm not even sure I want to take that bet. Who ended up winning the 2014 World Cup for predicting soccer results? Anybody knows? Cortana, yay! So Cortana was actually the winner of the 2014 World Cup, predicting 15 out of 16 games and knockout stage. And while we tried the same methodology, giving the Bing engineers plates of food with countries painted on them, didn't work so well. What did turn up working pretty well is predictive analytics and machine learning. And Cortana didn't stop there. It went on to predict the Super Bowl results. Unfortunately, we are all from, like Microsoft folks are from Seattle, so we're very disappointed that Cortana not only got who is going to win right, but also pretty close to the score. It's predicted a 24-23 Patriots win, and I think it was 27-23. And it did pretty well on the Oscars as well, okay, getting 84% of the recent Oscar nominations, so it was pretty good. And there's another thing that machine learning can do. Okay, there's another thing that machine learning can actually turn out to do pretty well, or at least pretty virally. Okay, what is this graph? Anybody want to take a wild guess? Yeah, on the back there. Ah, you're cheating. You're from Microsoft. When I put this, what is this graph? Anybody seen this yellowish box? That's the HowOld robot graph. And the 33 million number is the number of people that submitted photos into the HowOld robot application that we built over the last 4 days. 33 million people in 4 days. We're going to talk about that in a while. If you want to see some numbers, okay, so 33 million users, okay, at peak, 1.2 million visitors an hour to this website. Over 230 million images submitted. People really have nothing better to do in their time. At peak, 10K images a second, 1.7 million Facebook shares. And the funny thing is, we're going to talk about the behind the scenes of this demo and what in the Azure Machine Learning Marketplace and Azure in general actually enabled to build that. Nobody expected that, not even I that had the team that built this thing. But it was pretty funny. And talk a bit about machine learning in the real world. Okay. So this takes you to the USPS, our old favorite USPS, that as of even 2 years ago, processed, or still processes, 150 billion pieces of mail every year. And this is real mail, the snail mail, not the email kind of thing. And as of like 15 years ago, or 18 years ago, 10% of the mail was sorted automatically, but 90% of the mail, think of the astounding number, was still processed manually by people looking at the addresses and figuring out where does this need to go. Now, the reason for that, if it wasn't clear from the previous example on people, is that people are idiots. They can bother uploading 100 pictures to Twitter, but they can't bother writing the address on the letter, on the envelope, in a way that a person could actually recognize it. Anybody wants to take a guess what this word is? How about now? Referred. So what I've just done is train a neural network. Okay? This was actually deep learning, only it happened inside your brain. But the same thing can be done to train a neural network that is based on computer neural networks, or deep learning, if you've heard that term recently, and didn't actually know how this works. This is how it works, neural network 101. You take a bunch of labeled data, in this case, all these words that you all knew that they are referred, you feed them to a computer, either in your brain or in the computer, and you train a neural network. And then you feed it things that it doesn't know and tell the computer, go ahead and guess. Try and find out what does this look like. And assuming you trained it with enough data, it will get it right, just like your neural network got it right. So this can actually be done, and this is what the USPS actually did do using the data science team to train a computer, to train a neural network to read human handwriting correctly. And now they process over 98% of the mail automatically. Not a single person needs to read anything that's written on there, which is pretty cool. So we talked about predicting World Cup scores. We talked about predicting how old a person is. We talked about predicting handwriting. Machine learning can do anything. Okay? Over the last few years, everything was about big data. People were hoarding data. They said there was a joke that you can't go wrong by spinning up a Hadoop cluster or whatever. So everybody was hoarding tons of data. Unfortunately, if before it was very hard to get insights from little piles of data, now you have huge piles of, pardon my French, crap, and you still have not the slightest idea how to get insights from them. Now, the good thing that came out of all these huge pieces of four-letter stuff is that you can actually start using machine learning and predictive analytics to find interesting phenomena in your data. Whether it's product recommendations or customer churn or social analytics or whatever, you can still do it. And instead of talking all the time, I thought I would actually show you a quick example of what it means to use machine learning to enhance your business. So other than being a group manager of the machine learning marketplace at Microsoft, I am actually a shopkeeper. I have my very own Ziklik Mart, which I will show you in a minute. Ziklik Mart is my own very lovable, oh, sorry, ruining the fun here. No, whatever. So, oh, you're not seeing it. So I'm not ruining the fun, even better. Sorry, bugs in the session. What actually happened is that 3 minutes ago, my computer decided that it has a very, very important update that he has to install right now. So he shut down everything, and I had to restart my computer. I'm going to go back and talk to the Windows guys and tell them that they are all fired. But it shut down a bunch of things on my computer. So give me a second, and I will reignite them. True story, really. I think some guys were with me when it happened, and I was like, all is lost. But apparently, like, yeah, I know. At least it's not a blue screen. Yeah. Though, to be fair, it's my fault. I installed some Java update for something, and they're like all weird. True, it was like a Java security emergency update, whatnot. So all my fault, obviously. So all updates are done, and this should be back online right now. Okay, we're back. Just hit duplicate, you can actually see this. So this is my Ziklik Mart. This is my real store. It's a real website. You can go over ziklikmart.azurewebsites.net. I spin it up with Azure templates. Very nice. So this is my store. I sell a whole bunch of things. It's like a mini Amazon. And I would love nothing more than to have a frequently bought together widget. Okay? I saw it on Amazon. Everybody loves it. I myself, as a parent, add things to cart, add toys or whatever, see this, add 3 other things to cart. Amazon are making millions out of me and everybody in the room because of this widget. And I want that on my website. I want that on my Ziklik Mart website. I got the designer of the website to even do the placeholder on how this should look like. Now, how can I do that? Okay. I can either hire a data scientist, that mythical unicorn that everybody talks about, and get him to spend some time researching, I don't know, basket analysis algorithms or whatnot, and figure out how to do that. I can go and buy a digital marketing suite from whatever, IBM, Adobe, pay $100,000 and probably double than that in professional services, which I don't want to do. And that data science guy, I have nothing to do with him after he finishes doing this job. I can't hire him, he won't even come. But even if he did want to come, what would I do with him after 6 months? I'm like a small shopkeeper, e-commerce shopkeeper. So actually I'm going to search for frequently bought together. Maybe somebody out there actually figure this out. And the first hit that I'm going to get, and this is really, you can Bing search it or Google search it, is a frequently bought together API on the Azure Machine Learning Marketplace. Okay, this is a real one. Let me zoom in a bit. This is part of the Azure Machine Learning Marketplace. It's a real API. It's a real service powered by Azure Machine Learning. There's a bunch of APIs around it that I can use, but writing code is expensive. I have to get my IT guys to do some work, pay some vendor or whatever. I'm actually going to start by just looking at what does this thing look like and how good it is going to do. So I'm going to take all I need to do is take my account key. I'm actually already registered for this service, but signing up is easy. You just need to sign up with your Azure subscription. I'm going to take my keys. Don't worry, these keys will be dead after the session, so you can't use them to hack your way into my services. I'm going to do a demo right now, live Ignite demo. And now I have a couple of business decisions that I need to take because this is a frequently bought together service. Now, I'm not a data scientist. I really am not a data scientist, not just saying it for the sake of the discussion. And this is a question that I need to answer. What does frequently bought even mean? If two items were bought together once, is this frequent enough? Or do I need them to be bought at least 200 times to make them frequent on my book? So I'm going to pick a number, 6. And then I can choose what is the frequent set size. How many items do I want to return as frequently bought together? 1, 2, 6, whatever. I'm going to leave it at that. And then I need to train it with my own data. This is not a service that was pre-trained. It has to be trained on my own data, otherwise it's meaningful. How would it know what is frequently bought together on my shop? I have to train it. Now, I could open Azure Machine Learning Studio or whatever other tools and go and start building that. But again, I have not the slightest idea how to go and do that. But bringing in a file that says transaction ID and item IDs, this I can do. So I'm actually going to bring this kind of a file. Ignite. And I'm going to show you this. I'm going to show you this live in front of you. So you'll see how simple that is. Let me just zoom in a bit. So this file, anybody can take from their CRM or whatever database. It has transaction ID and item ID. So these two transactions, in this transaction, these items were bought. And in transaction number 2, items 1 and 8 were bought, and so on and so forth. I'm actually going to go back and upload this file. I'm going to click on the wonderful submit button. And now the magic is happening. So my data is getting uploaded. Some model is being created on Azure Machine Learning. Okay, there's some template or API sitting behind the scenes waiting for my data, preparing a model, training it, then publishing this model into a REST endpoint. So there's going to be a web service created for my data for predicting frequently bought together. And this endpoint is mine. I can actually go and use it, or not bother waiting, I can actually go and use it for my website to add a frequently bought together solution into the website. So I'm actually going to just paste these 3 lines of code and remove my previous image. And these 3 lines of code are all I need to power the frequently bought together experience. The first line is the interesting one. This actually goes into the marketplace, api.datamarket.azure.com, to the market basket analysis service, going on a model that's actually my pre-ready model. I don't want to spend a couple of minutes waiting for it, and gives me my account key and the product ID that I actually want to get the information for. Now, this would have resulted in item ID 1 goes well with 8, which is a boring and not something you can show a user. So I actually go to my database and get back all the information on that item, description, price, image, and whatever. And then just apply an HTML template that make it look like what the designer do on my board. I'm going to actually do save. So you can below this actually publishing it remotely. So I'm going to go back to my website. I'm going to go back to my website. I'm going to hit refresh on my browser. So you see that I'm not cheating. And assuming the demo gods are actually in a good mood this morning, which I certainly hope they are, yes, I get a frequently bought together widget on my websites in 5 minutes. And I absolutely don't care what's behind it. It's a bunch of algorithms, a priori, basket analysis, whatever. I don't care. I have a frequently bought together widget on my website that show me that this camera was bought together with a Paint Shop Pro, something, something, something. If I actually go and take a look at other items on my store. So I have, I don't know, a camcorder. Let's take this camcorder. It's a bit. So this video camcorder is frequently bought together with Adobe Photoshop Elements and whatnot. And I did that in front of your eyes in 5 minutes. This is what machine learning APIs are all about. This is how I use the power of machine learning to make my apps more intelligent. This is what I want. This is what I was going for. Now, So what is behind the scenes of this magic? How do we do it? So the answers to that is Azure machine learning. Azure machine learning is all about making machine learning accessible everywhere. If you think about the world of game development, then 15 years ago, if you wanted to create a game, you would have to start your own company, build the game, design the graphics, put it on a DVD, put it inside a packaging, go beg Toys R Us or Best Buy or whatever to put it on a shelf space, which meant that only the biggest like EA and Sierra and Microsoft could create games. Okay? Down came the various app stores. Now any idiot, that's a real favorite word of mine, any idiot can actually develop an iFart or a Yo, click on a button, publish it, and millions of similar idiots would download that app and use it. Any idiot, okay, can take some kind of algorithm, put it inside a website, and get 300 million people playing with it in 4 days, if only the algorithm exists. But data scientists, if you look at data scientists, if you look at machine learning, if you look at predictive analytics, it is still in that 20 years ago era. If you're a data scientist and you manage to create an algorithm that knows how to detect gender and ages in a person's face, as it turned out, people at Microsoft Research have done that 10 years ago. They've been working on that and improving it, but they've done it 10 years ago. And they want to get it in the hands of all the developers out there, of all the users out there. How can they do that? Well, they can't. They either start their own startup or start a consulting company that does predictive analytics door-to-door, kind of consulting professional services. We want to block all that. We want to get a new data science economy up and running by allowing those data scientists to bring in their smart and have everybody else who is not a data scientist, like pretty much most of the people in Ignite and Build and the planet, to use machine learning APIs. We want to get everybody on the planet using predictive analytics and machine learning in their apps, in their websites, in their day-to-day, because that's what makes the applications more intelligent. If you look at Excel, if you look at spreadsheet, at number crunching, 25 years ago, same thing. Every org had a person that knew how to crunch their numbers. If you want some numbers edited, you went to that person, gave them a piece of paper, and they put it in the computer and did something with it. Today, my kid is in elementary school, and he learns Excel. Now, my dad still goes to his admin and gives her the paper and have her do the thing in Excel, but my kid doesn't need me anymore. He does it on his own. We want to do the same for machine learning and predictive analytics. You want to take the producers, the smart producers that know how to use machine learning algorithms and potentially our Azure Machine Learning Studio, if you've seen it or not, and operationalize it and create a web service out of it, and then put it in a marketplace that all the wonderful consumers of the planet can go and say, hey, I can build an app with that. Just give me that Face API and I can build the most amazing app that everybody would like. Just give me that frequently brought together API and I will put it on my website. That's all I need. I don't care how it works. Yeah, I can tune it if I want in the APIs or whatever, but I don't care. 90% of the people don't care. They want to use machine learning and not necessarily produce machine learning. Now, with all the skeptics in the audience that say this will never happen, let me throw in another example. Suits. 50 years ago, when my grandpa wanted a suit, he went to a tailor to get a suit made. They would take his measurements, they would send him home, work on it. He came back after a week, they did some modifications, went back, came back, do some modifications. A long period of time, not a lot of money, but relatively a lot of money went into making a suit. Done. If I want to buy a suit, I go to a suit marketplace. Doesn't have to be JCPenney, could be something more tasteful or less tasteful. But I go to a suit marketplace, and for 99% of the cases, I can find a suit there that suits what I need. I may do some tweaking back home, maybe do something, put in a belt or something, but it's good enough for 90% of the people. So yes, the very, very rich one probably still get their suits handmade. Okay? In our analogy, some big companies may still want to have a data science department and build everything from scratch. Okay? Some companies may have a very, very, very unique thing that they would need to build on their own, detect tumors in brain CT images, though maybe they're on their own, there will be an app for that too. But for the majority of people, there is no need to actually go and build something from scratch as simple as frequently brought together. Just take it off the shelf and use it. There is no need to build an app that detects genders in images. Just take it off the shelf and use it. And I'll show you a couple of examples, which was the original title, of real customer stories using these APIs, like what you can do to enhance the business. So the first thing is actually showing you the frequently bought together in action, or at least telling you about it. So I've showed you on Ziglicmart, which is all very nice, but this is actually for real. One of our favorite customers is a company called JJ Foods. It's a UK wholesale retailer. It's a B2B business. They sell food and food and plates and whatever to kiosks and restaurants in the UK. It's a rather nice business. It's like a £200 million a year turnover. And they have some data science, but without any experience or expertise on this. So they actually went and used two services from the marketplace for recommendation and personalization, adding those things into the item-specific recommendations, really frequently bought together, what goes well with that, and also to the checkout-specific recommendations. Okay, you've put 6 things in your cart. What are the personal recommendations for you at this point? And very, very easily, it really took them a couple of days, maybe a week to finish the integration, got an uplift of 5 to 6% in their overall contribution, which is pretty astounding for a retailer. They made, within a week's work, $200 million times 5%, do the math. They made £10 million a year from a week's work. And believe me, we don't charge £10 million for what we provide them. It's a SaaS model, very, very simple, very, very cheap. Just integrate it. Could they have done better if they would have put in a team of 3 data scientists to work on that and do something that's super tailored made for them? Most certainly, yes. Is it worth it? In most likelihood, no. Maybe in a few years or a few months, they would actually want to get the next dot behind the line and make it a bit better and would actually go and build their own. But to get started, this is actually brilliant. And this is out there. If you go to the Azure marketplace, you'll see a machine learning category. But even better yet, if you actually go into the machine learning gallery that we have as part of Azure Machine Learning, so on the bottom screen, it's hidden, but you can see it if you go there. There's experiments. These are for the data scientists. These are for the people that care how this looks like and want to build their own. So you can start from a template, or you can start from scratch and build your own machine learning solutions. To those of you who want to use those, there's a bunch of machine learning API out of the box ready for you to use. Some of them we created, some of them our partners created, and hopefully that list will grow bigger and bigger and bigger as this becomes bigger and bigger and bigger. The first one on the far left side, which is what we announced last week and built, is the Face API that is actually powering the How Old robot. You can actually build your own. And I will show you some things that it can do. I want to highlight a few of the things that we already have in this machine learning marketplace, which again is rather new. So we talked about the top right too. We talked about the product recommendation and the basket analysis. I'm going to the bottom right. We also have services to predict customer churn and text analytics. And we actually have a super cool service for detecting anomalies. If you actually want to find out what's going on with your sensor data or your servers or your databases or whatever, I'll show you a couple of demos of all of those. We'll start with customer churn. So customer churn is a big problem. For every business, some of the customers leave. Can I predict that? Can I tell which customers are going to leave so that I can actually do some anti-churn mechanisms and engage with them? The answer is yes. If you give enough previous data, in the case of retailers, it could be transaction history. In the case of game studios, it could be game sessions. I can build a model and predict which customers are most likely to leave. Okay? And I'm going to borrow JJ Foods' example as well, because they're using this as well, and because they allowed us to share their data and do a bunch of nice things on this one. I'm going to show you this live. Actually, going to my homemade user experience based on the marketplace service. I'm saying that I'm doing that, but I'm actually not doing that. All this extend thing is wonderful. This is our service. Actually going to do duplicate because it's very hard to work looking like this. Okay. So this is our customer churn service. There's a cool movie that you can see it, but I won't do it right now. I'm actually going to just log in and show you some of the things that JJ Foods have done with this service. Just sign in. So there's a bunch of projects that folks from JJ Foods have done. I'm going to open one of them. And this is how you teach the churn service. What does churn mean for you? Okay. Not very complicated, a bunch of labels. You give it some pieces of data, in this case, 4 months of data. You tell it, what's the training period, 3 months in this case, okay? And what is churn for me? Churn for me in the JJ Foods case, those are the bottom 2 labels here, is 0 interactions for 2 months. Okay? In the Halo the game, it's 0 interactions for a week. In Age of Empires, another game, it's less than 3 interactions a day, which is a pretty depressing thought. If somebody is not playing Age of Empires 3 times a day, they are considered a customer that is churning, which means that everybody else is playing it more than 3 times a day. Going back to what people are doing in their spare time, apparently it's not just uploading pictures to the Howard robot. So I did that. That's all I needed to do to train my model. Now I'm actually going to see the stats of this training of the model that I already built. So I see a bunch of machine learning numbers, area under curve, and actually normal numbers, users that churn, users that maintain relationship. I can see some charts that says how good this prediction is, ROC, curve, whatever. Really don't even want to bother with those. And I can go and use it for scoring. Here is new pieces of data that you haven't seen, the model hasn't seen. Tell me what you think of those. I actually already have an example that I opened. These are the results. And what you can see here is real user IDs. The scored label, 1 means likely to churn, and this is the probability. So for every user ID, there's a probability that is going to churn. Now I can go, take the top 200 or 400 or whatever, and do something with it. Send them an email, give them a call, whatever it is that I want to do for anti-churn mechanisms. In some of the game studios, you can send an email saying, yeah, you just won a gold pack or a chance to kill a random monster or whatever. In the JJ Foods case, they actually go and do some special offers for those customers. And the end result is, again, pretty good. Our predictions for the top 20% are actually 3 times better than random. If you look at the top 5%, like the top customer that we're actually super sure that they're going to churn, it's 9x better than random. So if you take a random user, or the users that we predict are very, very likely to churn, we are 9x higher chance that they're actually churning. And it's not just that. JJ can actually do something about it. Out of 200 predicted users that we say these are the top 200 that are going to churn, they managed to retain 45%, versus a random 200 users, only 17% retention rate. So 28% out of 200, that's about 50 customers every month that they manage to keep. And this is a B2B business. There are 50 businesses that stay with them at least for another month. That's a pretty cool thing. And all they have to do is, again, upload the data, click on the magic button, download the results. So you can do it manually with the user experience, just like I showed you. And obviously, you can do it via an API. Everything here is powered with APIs that you can actually go and integrate into your own backend services. And there's more. Text analytics is a good example. There's a ton of people and a ton of companies that know how to do social sentiment. It means you give them a word, they go to Twitter or Facebook or whatever blogs and say, what is the sentiment on this word? Try Obama, try whatever. So in some cases, that's a useful thing. In some cases, it's a bit more challenging if I put in words that are associated with Microsoft, like Windows or Office or Surface. It's a bit of a challenging to figure out when somebody's complaining about Windows, Office, or Surface, and when they're just complaining about some window or some Office or some Surface. Okay? Xbox is probably easier, so that's one problem. And the other problem, it's freaking boring. It's not interesting. Why do I care what some random guy on Twitter is saying about my brand? I want to talk to the people that I care about. I want to see the people that submitted something on my web page, went to my web page and put a comment there, went to my Twitter page and put a comment there. You know what? Open the case for support. I want to look at that and see, how am I doing? What are the support cases that people open on me? Is this interesting or not? And as it turns out, this is becoming a bit more difficult, especially if you want to do things like, especially if you want to do things like, you can hardly see it, but figure out what are people talking about. This is becoming difficult. This is becoming a natural language processing problem. This is becoming a data science problem, a real data science problem. If you want to do things like triaging customer support issues or extracting things from user reviews, this is turning into a problem. Now, as it turns out, we at Microsoft have technology that has been winning entity extraction cups for the last 5 years. There's two astounding facts about that to me. One, that somebody is bothering to hold these kind of cups on entity extraction. So apparently there is. And B, that we're winning and nobody knew about it. And that is also true. Nobody knew about it, but those researchers that are actually competing in that. But we are actually leading in that space. Why is it only usable by Office and Bing and Xbox? Why can't anybody else that sit in this room, sit on the planet, build something using that? So I actually took that technology and we're starting to put it out there on the machine learning marketplace for you to use. I'll show you a quick example. So this is the Azure Machine Learning text analytics piece in the marketplace. Okay, so you can actually go and see it. Can you show you it in the gallery as well so it looks a bit better because the gallery is new, the marketplace is old. We're working on that. This is the text analytics piece. So you can see a bunch of details and sign up and sample code and documentation, whatever. I'm actually going to go again to the right now. I have this kind of funky user or simple user text generated piece. Now, I'm going to put some text into it, and the text that I'm going to put is I'm going to go to my hotel. I actually needed to pick a hotel for Chicago, so I went on and read the reviews. And you know what the funny thing is? I end up staying at this hotel, which is actually a new hotel. But even with this new hotel, if you look at the left-hander, there's like 49 excellent reviews and 1 terrible. If you actually go to any like older hotel, there's like 6,000 reviews, 600 terrible, 300 poor, 300 average, 600 very good, and 5,000 excellent. Now, I wouldn't bother reading through all of those. I don't want to go and try reading through to see what the problem is. Maybe I'm very sensitive to, I don't know, noise. Okay, so if everybody likes the hotel, but those are the people that don't care about noise, and there's 500 bad reviews of people that claim this hotel is noisy, oh, that's I don't want to go there, even though the overall review may be 4.5. Figure the other way around. Maybe some of the reviews are complaining about, I don't know, the kitchen is the food in the restaurant is not tasty. I'm like, I don't care. I can go eat somewhere else. I don't care about that. But there's no way for me to know. I have to go and read through thousands and thousands and thousands of reviews to figure out what's going on. And if I'm the poor hotel manager, that's even worse. I actually have the API to go and plug in and reply to anybody that says a good or a bad criticism. But I have to go to TripAdvisor and Booking.com and Expedia and probably 17 other sites that I forgot and read all this junk. And all I want to know is what is the overall sentiment and what are people talking about? So I'm going to take a random review, just whatever. I hope this will work because really it's a random review. Where is this text analytics piece? I'm going to paste it here. Oh, that's wonderful. I pick up that review. He's staying across the street at the Sheraton. Wonderful. That guy is staying across the street in the Sheraton and he writes a review on the other hotel. Brilliant, brilliant guys. Did I mention that people are idiots? But even on this one, okay, you can see the overall sentiment, which is nice, and you can see some keywords that come out. Looking rooftop pool, end of April, Chicago, summer location, Miracle Mile. Actually, if I go, I actually can start harvesting all those pieces of information and start generating things about my hotel like this. What is the overall sentiment over time? What is the key phrases that people are talking about? Okay, this I actually went and generated from the Lowe's, okay, the hotel that I'm staying at. And this is the word cloud on positive sentiment phrases. Okay, not just saying, okay, this is positive, this is negative. You can go to TripAdvisor and say, oh, I can see the stars there. But figure out what people are talking about. So apparently people like the front desk, people like that it's clean, people like the view, people like the linens and carpets, and by the way, they are amazing. Like the bathroom carpet is like the softest thing I've seen in my life. Apparently I'm not the only one that thinks that, and a lot of people are tweeting on that. These are things that are super useful. Now building that yourself, taking all those pieces of text and running through thousands of those, that's a nightmare. Calling an API, bringing all my pieces of text, calling an API and getting back the results, that's super trivial. I can do that in minutes. So that's a nice thing. And it's not just about what people are saying, it's also about who is saying it. Okay, if I actually know who is saying that, if I actually have a user-generated content website, a Facebook or a Twitter or whatever, I can actually start figuring out what are people saying about me. So on the left-hand side are my fans. User 77, 69 times he wrote something about me, and the sentiment is wonderful. Maybe I should use them as an evangelist, contact them, offer them some promotion. On the other hand, user 1723 or whatever is pretty nasty. 8 pieces of text, all negative. What's wrong with you? Let's talk to that guy. This kind of thing I can do, but not just on Twitter. I can bring my own data. I can take the cases people open on my dynamic CRM. I can take the call center transcripts, all the pieces of text that people generated on my business, that's my data, and bring them to these kind of services and figure out what are people talking about with a click of a button and signing for an API. And it's not just this. It's not just, somebody removed here an amazing picture that I had of a 3-eyed Simpson fish. I guess it was copywriting. Ah, well. It's not just these things. It's also about not just the classic retail things. It's about anomaly detection. We have a service that does time series anomaly detection. That's a very frustrating problem, especially if you do any operations and you run services or businesses. So it's actually an old slide. It should say Azure DB. This is Azure DB operating the service using our anomaly detection. What they actually do is they upload certain, I call them sensors, but in a sense they are counters, from those service logs into this service. So think of queue latency, number of failed logins, number of errors, things like that. And this service automatically detects anomalies using machine learning. The problem today is that detecting anomalies is easy. You put somebody in front of the screen, you put a rule that says, when this threshold goes above 60, throw an alert. Then you come in the morning, you look at the dashboard every morning, this is for our services, every morning you get 70 severity B alerts. I'm like, okay, what am I doing with those? I can't analyze 70 severity B alerts, so just ignore them. You're turning yourself numb into problems because there's so many of them. But go use this kind of service, and it learns about the patterns of your work. So if every Monday morning at 8 a.m. there's a spike in traffic, for the first time you would get an alert. For the second or third or fourth week, it will learn that spiking at Monday morning at 8 a.m. is actually normal. That's fine. No alert is needed. The service picks this up because it's machine learning. You can train it on your own data, bring in data from your own services, from your own sensors, and it learns what is the normal behavior and when alerts should be fired. And this can be done for IT-related stuff, like I just mentioned, or for predictive maintenance on elevators, or the Stanford Linear Accelerator are using that on those sensors, humidity and temperature sensors, to detect when something goes wrong. Okay. Because if something breaks in the Stanford Linear Accelerator, it's not just $1 million a day or something. It's researchers that have been waiting 4 years to run their experiment in the accelerator and have to go back home. So it's very, very important that nothing breaks. So they use that. They feed it into the service to detect when anomalies happen, which is actually a super useful thing. Now, for the last minutes, like 10 minutes and then open it to questions, I want to take you back to what we started with, talk about behind the scenes of the how old robot phenomenon, and introduce you to Project Oxford, which is something that we just launched last week at Build, with the goal of actually getting people the opportunity to understand what's going on around you. We talked about retail stuff, frequently bought together, churn. There's going to be a bunch more of those down the road. This is about taking our own homemade technologies, the speech that powers Cortana, the images technology that power Bing and Xbox, the face recognition technology that powers a bunch of other services, and give it to everybody else. Okay, let everybody else use these kind of services in a pretty useful way. So I think I mentioned some of those. So Project Oxford has face, vision, speech, and language understanding. I think it'd probably be easier to just go and show instead of just reading. So for Face API, you've seen what Face API could do with something like How Old Robot, where you can actually do age and gender detection. But it can actually do a lot more. It actually starts with detecting whether there's a face in an image. Okay, just detecting the face. And there's a actually side effect of that, if you see here. It detects age and gender. But it really is a side effect. It wasn't designed in the sense of, let's be the most accurate thing on the planet. Okay? Though it is pretty good. Remember, it's how old you look. It's not how old you are. If Madonna does 20 plastic surgeries and has the skin of a 30-year-old woman, the service would think that she looks like a 30-year-old woman, and that's perfectly fine. But if you're thinking about what can I do with these, and over the last few days, we've had a bunch of developers, we have over 1,000 developers signed up to start using these services, a whole bunch of weird things come out. For example, there was a session around that, I think, by NEC, but with their own technology. I can provide in-store coupons to people, and now I can provide different coupons whether a mom walks alone into a store or a mom with her kid. Now, it doesn't really matter if the mom is 35 or 37 or 41, but okay, these are 40-year-oldish people, these are kids, and these are old folks. There's actually a railway company that is starting to use this API to monitor what's going on the train stations. When are people over 70 coming to the store, to the station? Because that means that I need certain kinds of people to help them. When are teenagers coming to this place? Because actually I need some other kind of people to be helping them. Okay? These are things that nobody even thought that are doable in the past. No developer inside those companies could do. And actually now, with a click of a button and a sign up into a service, you can actually go and use. And of course, there's verification and recognition and grouping folks together and all this kind of thing. But it's not just that, and potentially even recognizing. It's not just about faces. It's about starting to analyze images, One of the most annoying problems with user-generated content, websites that you have, is that it is generated by users. And if you remember the repeated assumption on this session, users are, the rest. So if Purina is holding a competition that goes like, take a picture of you doing a fun thing with your dog, upload it to our website, and you will win potentially a lifetime supply of Purina. The things that people think about is fun with their dog is a very unique thing for every person. Okay? If Starbucks wants to hold a competition and say, take a picture of a cup with a Starbucks logo, draw something on it, upload it to the website, and the best one will win, some people would actually end up drawing, to say it mildly, inappropriate things on their Starbucks cup, or doing inappropriate things with their dog and uploading it into some public user-generated content. True story. Now, the result for that is either sitting out a team of 100 people that will go and filter those, at best pornographic, at worst, even worse than that, images, and do something with those, or start developing some technology that will know how to detect mature content. Now, as it turns out, we already have one. It's called Safe Search. Anybody that goes into Bing and toggles those Safe Search warnings from strict to moderate to whatever, there's a super cool machine learning neural network technology behind it that knows how to detect adult content. We're actually super good at that. We're the best on the planet. Now, how about you guys using it? Just upload your pictures and get back some indication via an API that says, what is this picture about, and whether it's an adult image or not. How about you do that? And then, and you actually can do that. If I go back to my gallery, and I go to the Vision API, and I hit try it now, I can upload any pictures that I want. Let's take this one as an example. And again, it's like the howworld.net. You can upload any picture. This picture is obviously not adult. Okay, so the adult score is super, 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 super low. And the racist score is super, super, super low. Oh, that's actually good to know. This picture, still not adult, but potentially very racy. Okay, this one, absolutely no adult and no racy. Now, there's an API for that. There's an app for that. Just plug against that API, upload all your user-generated content, and get back a score that you can use for whatever it is that you want. Pretty useful, pretty cool. Just not just about faces either. Yeah, question. For what? For this? No, this is actually, the question is, are you giving me a logistic regression kind of a thing in the background? That's not even the question, but actually no. There's a pre-trained model that's been trained by 6 billion images that were labeled with a huge neural network, actually 100,000 of those, that is powering that.
Okay, so a lot of times we do a logistic regression for a binary and true. Is there a confidence interval that you're giving out for that, for these particular APIs that you're?
Yes, so the question is there a confidence interval that you're giving? So the actual answer is yes. As you see, there's actually is a score, okay? And there's a confidence threshold that you can set that defines whether the result is a true or false. Okay? And you can control it, okay? You can actually control and say above this amount it's true, above this amount, below this amount it's false. There's some defaults in it based on what we think it, but you can actually do it differently. If you think that you want to err more on the safe side, you can change that. So you can set the adult content flag, the binary classification as you call it, or you can trust our service, but in any case you actually get the score. So you can use it and do whatever it is you want with it, in this service and in any other service. I can show you some other fun things about this service. It's not perfect, again it's in preview, but if I upload pictures of this thing, it says this is food bread. Okay? And there's a bunch of categories that we actually trained it to detect. So this is food bread, and this is whatever this is. This is outdoor. Okay, fine. So you can now start playing with images and start doing interesting things with images. And by the way, not just images. Going back to the Starbucks example. So some pictures were obscene, but in some cases, it wasn't the picture that was the problem. It was the text there. People were writing, or could write, Starbucks sucks, or Microsoft, I hate you, or whatever. And that's not, an adult classifier would not detect that, but an OCR with an adult classifier on that text actually could. So we have that as well. Bring me a picture, any picture, and I will do OCR for you. Now, OCR has been around for a while. You can download your own OCR client or whatever and use it. But why would you bother? There's a service that does that and does it amazingly well. Just upload your picture, and I will tell you any pieces of text that were on that picture. Take a slide deck, upload it, and I will tell you what was the text on that slide that you can use for indexing or whatever that you want. And there's another service that I won't even show you that's called Moderator. Moderator is about moderating pieces of text and actually images and some videos and whatever. So take the output of this service, feed it to the moderator, and you will detect all the profanities and curses and whatnot that people are uploading on their user-generated content. We use it for a while. We use those services inside Bing for safe search, for Skype and Xbox avatars, so people don't load inappropriate content into those. For all the user-generated content at Microsoft, you actually screen it with those services for content moderation. Now, anybody can do that. It's part of the machine learning marketplace that we actually put out there. And you can go and discover it yourself. You can actually go, like my last two slides, you can actually go into the Azure marketplace, the Azure Machine Learning Gallery, and find out everything that's there. I've showed you a couple of quick demos. There's a new speech API, also came out last week, super cool. The exact Cortana technology available at your fingertips for doing speech-to-text, text-to-speech, transcription, real-time speech-to-text, whatever you want. We have customers using it for call center transcription, and then sentiment analysis and key phrase extraction, and then Power BI to show some cool word cloud thingy on top of that. All can be done. If you're on the other end, if you actually have some IP, if you actually have some predictive analytics, machine learning technologies and capabilities that you want to share with the world, bring them on. We welcome all publishers. Bring them on. You want to see them in the marketplace. We already have some partners working on that. Some are already there. Bring them on. We want to see that and enable that new data science economy. Everything that we just showed you is just to bootstrap the marketplace. That's the only thing we're doing. We're bootstrapping the marketplace with some cool stuff to get everybody excited. But this is a marketplace for everybody. We want to see everybody put their stuff out there so that everybody else can go and build their how old robot crazy thing. And I was asked to add this slide. Apparently there's an Azure Challenge sweepstakes something. If you actually attend those Azure sessions, like this Azure Machine Learning, you can win raffle tickets for a bunch of crazy things. So just enter this 4-letter code of the session online, and you get a chance to win sweepstakes. And last thing, evaluate the session. Your feedback is important to us. Okay, I want to be number one, so make sure that you evaluate. If you have good feedback, write it down. If you don't, don't bother going into the website. We don't care. Open it for questions. Yeah, on the back.
And I apologize if I missed this somewhere along the way, but the confidence in the back-end processing. So let's say, someone submits out there and they're a terrible data scientist, and you're using the frequently bought, items, and it turns out, because you're not seeing all the processing behind it, that their algorithm is terrible. What's going to be the mechanism for knowing? Because we know when we buy an app, oh, my phone froze, or, you're starting to get that feedback. But you might not be able to tell if their analytics is good or not.
So the question was, what if some random data scientist goes and builds an algorithm, puts it in the marketplace, and it's bad? It's just not working. So that's actually a good question. So I'll provide two answers. Okay? The long-term answer, it will be just like app. Okay? When you download a flashlight app to your phone, there are 600 of those, 590 are shitty, 5 are fine, and 5 are great. In the end, the community sort of lets you wiggle out what's work. You usually take the things with the best reviews, the best usage, the most popular, the whatever. And
Idiots are downloading, so we're also being careful with idiots.
I completely agree. So long term, the power of the idiots, okay, when you get a lot of idiots together, that's called, the name just, brain something, I've lost the word, I'm an idiot. The power of the community is like, in the end, it's pretty good. But you're absolutely right. You shouldn't deploy any production service for an enterprise without testing it first. So what you should do with any service, just like the churn service that I've shown you, and by the way, it may not necessarily even be a bad algorithm, it may be a bad training data that you provided, is test it first. Before JJ went live in production, they actually did a control group. They tested that, they did some A/B testing and said, oh, well, it's actually pretty good. Before Dell are launching the use of the recommendation service live on the website, they do A/B testing. They light it on limited amount of people, see the uplift, see the clicks, and say, okay, you know what, it's pretty good. Down the road, we will probably have some kind of built-in A/B testing platform that you can actually go and say, okay, for this service, these are the numbers of users I want to use like that, and these are the numbers of users you want to use like this. We don't have that, so it's on you to build that. But I would highly recommend to do that, okay, to make sure what you deploy is useful. It's less critical in the sense of pre-built models, like text analytics or adult, because these are things that have been trained and signed by Microsoft or whatever. But in the case of bring your own data or some random provider, you have to do some A/B testing and make sure that you're not doing anything bad to your business. That's absolutely true. Questions? Yeah.
Yeah. So in the ML world, are only supervised learning models supported, or do you also support reinforcement learning?
Do we support supervised or reinforced or unsupervised? We actually support all of them. You can build with Azure Machine Learning, you can build whatever you want. Services tend to go, like the finished APIs tend to go in the unsupervised angle because usually the users don't know how to supervise. So they go more in the unsupervised kind of a thing, but you can build whatever it is you want. Some of the services that we even launched last week allow you to even build your own model from that service. So upload your label data and train your own speech model because you deploy your app in Wales and they speak English differently. So you can actually even build your own models using those finished services. So it can do everything you want. What we're seeing is that most finished services are aimed at the developers and so are more unsupervised kind of a thing. Question on the back, yeah.
Can you explain why the swimmer was 27 in your slide deck, but 28 on the website?
Why the what?
The swimmer, picture of the swimmer, was 27 in your slide deck and 28 on the site. Is it?
The service is live. The technology is alive. People are continuously updating and improving and training it on additional data, so there may be some changes that result from new data that comes in.
So they are training, so there is a feedback mechanism.
Yes.
You're saying that was not right.
There is some API to actually do that. I don't know if on this specific service there is or not. I don't remember the details of the service, but there is an ongoing. This is the same service that powers other things at Bing and whatever. So there's ongoing mechanisms that continuously retrain the service that we build for you guys. So it may be that I took a picture a week ago or 2 weeks ago and whatever it changed. I actually don't know. It's good that it's 27, 28. I was saying, you say 27 and 60. That would have been a bit more concerning. We've seen that as well. But the service is live. It really is alive. Questions? Yeah.
If anybody uses these web service that's available on the marketplace, what does Microsoft do with data?
So each service has their own terms of agreement. Okay. Each has their own. The services usually where you bring your own data for training, then this data is saved only for you. We cannot use it for anything, not for retraining our models, not for retraining anybody else's. This is data that is stored on your account, on your key, and only for you. Nobody else can do anything with it. Some of the services have different terms where you say, okay, we can use it to improve our own models. It really depends on every service has their own terms of use. Usually the services that are bring your own data kind of a thing we don't do anything with your data. It's only held for you. In the Face API, sorry, not in the Face API, in the howall.net case, in the app that everybody uploads, we don't do anything with the photos. We don't store them. There was a bunch of like talks on the web. We don't store them. We don't use them. We don't do anything with them, really. I know in the terms of service it says that we can basically do anything, sells those pictures to Satan or whatnot. We actually, in this specific, we could, but in this service, and we put the label, we don't do anything with the photos in this specific service. Yeah. So if I want to use a service with my own data, what about incremental continuous training? So some of the services support that already. For churn, for recommendations, for these kind of services, it's already part of the API. You can upload your data incrementally and train based on a period of time that you select on everything or just subset. That's part of the API. It's per service. It's stored in your, the question was, is it stored in my own data set? It's stored in your own place inside Azure ML, and you're the only one that can access it with your credentials. It's stored for you. Yeah, question here.
If there were like data security or privacy concerns, could you actually do this all on-premise?
So could you do all this on-premise? So right now, Azure Machine Learning is only available on the cloud as part of Azure. With the acquisition of Evolution Analytics, which just announced a few, I think, weeks ago, so a few weeks, a month ago, we're actually looking at ways to enable some of this to actually transition into SQL Server, vNext, and these kind of things. But right now, everything that you've seen, most of the things that you've seen here are on the cloud only. Some exceptions, Project Oxford, actually, some of its APIs, the Face API, the Speech APIs, are also available as client libraries. You can actually download them and use them on Android, on iPhone, on PC, on whatever. But in general, Azure Machine Learning is a cloud-based. There are some exceptions to that. Yeah. So how do I charge on the gallery? So the whole point of the gallery is just like any other marketplace. You charge. You say how much it's going to cost. The tiered pricing are yours. And we take our marketplace cut from it. So you actually say how much you want to charge per 1,000 transactions, per 1,000,000, per whatever. You can keep everything free of charge. You can charge $1 billion, whatever it is you want. We take our marketplace cut. I think it's 20%. We take that cut. But it's up to you to decide the prices. We just, like a marketplace, we get the money for you, send you an invoice at the end of the month, and you're done. Question here.
I have a robotics application for this, but unfortunately the robot needs to operate in an offline mode. Is there any way to be able to take the model that is generated in Azure and modularize that and place that?
So the question is, is there any way to take the model that was created in Azure and use it offline? So in general, no. For the Face specifically, yes. So I think I mentioned it. The Project Oxford modules, I think all of them, or maybe almost all of them, are actually available as SDKs as well. You can actually download and use on-premise on your device on whatever it is you want.
So I mean, it's technically possible, this isn't available to service yet. So
it is available. If you
for a custom application, custom engine.
So again, in general, Azure Machine Learning is on the cloud. Okay? Some specifics allow you to do anything you want on-prem. Azure Machine Learning also, for example, allows you to create your models from R and Python and whatnot, so you can actually take that and run it on Revo Analytics or whatever. But in general, right now, Azure Machine Learning is not available on an appliance or an on-premise kind of a thing. It's available only on the cloud, with the exceptions of Oxford and some other things. Any other questions? Yeah, one last question.
Is there something online that distinguishes between pre-trained models and those that you train?
So every service, is there something online that differentiates between pre-trained models and models you can bring your own data? Every service has their own description and APIs, and for every service you'll see whether you can upload data to train it or you have something pre-finished that you can build. And again, it's not something that is permanent. Some of the services that right now are pre-trained will actually expose retraining APIs for your own data on them, like text, for example. Yeah, last one.
Can the service reach out to data, or does it have to be uploaded?
Data right now has to be uploaded to the service. Thank you, guys. Hope you had fun.